Welcome to PyMath. Let's look at this question which appeared in the Caribou test, grade 5-6 during the year 2023. The question is as follows. What is the number of distinct, not identical after rotation or mirroring, scalene triangles with integral side lengths with a perimeter of at most 12? So the requirement is that this is a question associated with a scalene triangle. Let's take the sides as to be A, B, C. So the sides A, B, C are all different lengths. So again, that is a requirement of a scalene triangle, which is given. And these are all integer lengths, so there is no decimal involved with these lengths. And the perimeter is less than or equal to 12, which is at most 12, which is given. So these are already given in the problem. So what we got to find out is how many scalene triangles can you form with a perimeter of less than or equal to 12, and there is no decimal involved with this length of the sides. So the fundamental requirement of a scalene triangle is that the sides need to be different, but the requirement or the property for sides of a triangle with sides A, B, and C is that two sides should be greater than the third side. So this requirement has to be met for picking any three sides. And we have a bounding condition here. Perimeter should be less than or equal to 12. Let's start with the first side being 1. So if you take 1 and if you take the next side to be 2, as I said, the third side should be less than the sum of these two sides, the first two sides. So when you look at the third number, the minimum being the 3, this cannot be a sides of a triangle, just because if you add 2 to 1, it becomes equal to the third side. It means this condition cannot be satisfied. So that's why you cannot have a scalene triangle with one of the sides being 1. The same applies to if you pick 1 and another side as a 3. So for the third side, even if you pick 4, sum of these two becomes equal to the third side, which does not meet this requirement that the sum of two sides should be greater than the third side. So this requirement is not met. So you cannot have a side with length of 1. So let's look at, let's say these are cases associated with 1. Let's say the cases associated with a side length of 2. Let's start with 2. Let's say the second side is 3. Thinking about the next option is having a 4 here. If you add this 2, we get 5. And if the third side is 4, we satisfy this condition, A plus B is greater than C. So 2 plus 3 is greater than 4, and so as when you add these two sides, it's still greater than the 2, and when you add 2 and the 4, it's still greater than the 3. So these requirements of having two sides, if added, is greater than the third side is met. So 2, 3, 4 is an option where you can have a perimeter of less than 12. In this case, it's 9 units is a perimeter. So this is a good case, case number 1. Let's get to the next possible, if any, associated with a side being 2. Let's say I start with 2, 3 is already done. So let's say my second side is 4. So let's say I have the next side to be 5. So these two sides added is 6, which is more than 5. These two sides added is still greater than 4. And 4 and 5 added is 9, which is greater than 2. So 2, 4, 5 is a possible option which satisfies the requirement that we discussed. So 2, 4, 5 is the second case possible with the side being 2. So beyond that, if you take 2, 3 and 4 is already taken. So let's say I take 5. So this already adds up to 7. So the most with respect to perimeter that we can get up to is 12. So the only possible way is that you can put a 3, which is already, if you put a 3 here, so you will get a 10. But these two added is equal to 5. So this is not possible. So, and even if you get to 4, so this 2 is good. This side is good. These two sides are good. And then when you add 2 and 4, 2 and 5, it's still good. But this is exactly the same as the case 2 that we already discussed. So there is no other option for 2, which would be having 2 other sides if all added would give us a perimeter of less than 12. So we are done with sides starting with 2. Let's look at, is there any other option? With respect to 3, if I put the second side to be 4, and so this adds up to 7. So if I put the third side to be 5, this is good because when I add these two, this is 8, which is more than 4. When I add these two, it is 9, which is more than 3. When I add these two, I will get 7, which is more than 5. So 3, 4, 5 is an option to have a scalene triangle with perimeter less than 12 or equal to 12. So in this case, the perimeter again is actually 12. And then when I get to other options like 3 and a 5, the problem is this one adds up to 8. So this side should be less than 8. Even if I put a 7, this won't work because when I add all these 3 numbers is more than 12. So right away, we cannot have a perimeter of more than 12 for this problem. So other numbers won't give us anything, like having a side starting with 4, 5, and the only other option is 3 to have a perimeter of less than 12. But the problem is 3, 4, 5 is already taken care by our option already discussed. So there is no other 3 numbers which can form a scalene triangle to give us a perimeter of at most 12. So we have 3 cases. So the answer for this problem is 3. Thank you for watching.